then I will just get started right away. So, oh no, actually, I think I will not start with the slides, but rather with something to show first. Yeah, because I think this is what this is about, and what we were also discussing in the podcast, and why you asked me actually to do this. So I was always like feeling that when you do design studies with a CFD, or you just have a lot of CFD results and you really want to get some insights from the results, for example, to find out which parameters do have which impact onto your objective functions, for example. So when you do a DOE, or you run an optimization, and that then sometimes it's like even if you have automated the whole process, and so you also have your automated post-processing, of course, so afterwards you can screen through the results. I personally always found it a bit hard to really compare the different cases with each other. So to really, like, I don't know, going through the different folders, opening up PNG files, looking at contour plots, and so then really having files open all over the place, so then can get a bit crowded. So this is the one thing where I felt like, so I feel this should be handled in a different way maybe. And also I feel that especially when you run optimization, and as I said, even if you have automated the whole process, at some point you still need to do some kind of visual sanity check. So yeah, because your optimizer might point you to something what looks really great, but then still you have to check the results really thoroughly to make sure that the generated geometry, or that everything actually is really good and works as expected. So that was kind of the motivation why I decided to build like an interactive browser-based dashboard with which then you can like really screen through results and really check them at the same time, and like really allow you to find out about the impact of different parameters. So we will check this out later a bit more in detail. Then I will guide you a bit through this. But before, I want to give a short intro into Streamlit. Because I mean, when I decided that I wanted to build something like this, I was looking for an appropriate tool to do that. And I mean, I can code Python, but I'm not a front-end developer or anything. And also, to be honest, I mean, of course, I also looked into Dash and other tools for building these kind of dashboards, but all of them, I found that the learning curve is actually a bit steep, and that it just takes some time until you get actual results. And that's just why in the end I ended up with Streamlit, and I'm still using it. And so every time I want to build something just like real quick and want to show something, then Streamlit is always my place to go to. So maybe also at first just a little bit about my background. So my background is in mechanical engineering. So I have a PhD in computational sciences, and I've worked in the industry also in CFD as R&D engineer, and then I also added some data science capabilities during my work at Siemens and Rolls-Royce. And right now I work as a product manager at Neural Concept. And actually, since since I got started to dive a bit into the whole data science topic, I really felt that my mission is to bring data science and machine learning into engineering, and there especially to connect it with simulation, because I really felt that simulation is like the best use case in engineering to apply any kind of data science or machine learning, because all the data is already there. So if we have our processes automated well, then we have a perfect database which we just like need to use or make use of it. And yeah, so this is really it's my passion topic. Yeah, so this is a little bit what I said already. So why develop an interactive browser-based dashboard? So it's the one thing is supports the process of understanding the data. So that's actually what I already told about the motivation. So investigating the impact. Yeah, then actually another point what is mentioned here and what is also important. Probably you also came already across this problem. So you do have a meeting, and then you are asked to present actually results of your work, or yeah, you have made a design study, you came to some conclusions, and then you created some plots, and you put these into your slides, and everything is like a bit static, and then you are in this meeting, and then someone will ask you, yeah, okay, so I do understand what you show here, but did you actually also check out the relationship between X and Y? And then if you don't have this plot at hand, then the process of discussing the results just gets a bit stuck, and then you end up with follow-up meetings, and you go back and generate these plots again. So also they're having something which is a bit more interactive, and what you can actually also show and share during a meeting. It's that's also something pretty nice. Another point, of course, is also the collaboration topic. So if you have something which is really browser-based, then you can share it easily. People at different locations can look at the same stuff at the same time. And also something what I feel is also nice, especially for the CFD related stuff, and where actually a lot of these post-processing tools require licenses, is you can share results, you can have other people look at the results without any special software or hardware requirements, without any kind of licenses. Yeah, then also again, like, why Streamlit? So yeah, as I said, it's super fast. So you see what you do while you actually code and while you go, and it just takes 2 lines until you see the first things. As I also said, it's super easy. So if you can write code a bit in Python, then that's totally enough. And what I also found extremely helpful is that it's really a growing community of contributors. And so I mean, what we always do, if you run into a problem or if you want to do something specific, then you can just search in Google, and you will find answers to like everything. Yeah, then it's what I also found, what made it easy for me is like that the code is really run from top to bottom. So there's not the paradigm of callbacks actually. But then if you are like really experienced and you feel that, okay, I want to do something what is really special and it's not yet implemented, then you actually are able to create your custom components as well. So then you can actually also integrate any kind of JavaScript code what you would like to have. Yeah, and then yeah, you can really also do online development. And what is really nice is so Streamlit now also offers to host your created dashboards. So if you make them publicly available, then you can host them in the Streamlit cloud for free. So yeah, then, but yeah, with some of the advantages actually also come some disadvantages and limitations. So what is nice on the one side, whether from top to bottom, because it's easy to understand and that you don't have these callbacks, it sometimes can make it also a bit tricky because like as soon as something changes, then the overall code is run again from top to bottom. And if you don't want to have this, if you want to keep certain states, then it gets a bit more complicated. Yeah, another limitation is also that if you really have large data sets, and so everything is based on client-side rendering. So if you have large data sets, or especially if you do like scatter plots with a lot of data points inside, then it can get quite slow. And then of course it also depends on the hardware of the respective client who is checking out the web page. So yeah, as I said, we will also afterwards take a look at some of these dashboards which I have created, and what I think can be nice showcases. Yeah, then also because I think I will share the slides later on with you. So I just documented some. I just put some links to some docs and resources here. Yeah, and then after checking out some of the dashboards, we will come to a hands-on part. So we will build a basic dashboard, but they're already with some basic widgets and how you can change the layout, and we will also check out what you have to do to deploy this dashboard for free. Okay, so with this said, so let's first start with one of these example dashboards. So this one is actually built around a design study. So I can show you here, or yeah, basically you can also start with this. So here you can see that you actually can also select path and data files, which will then read in and are processed. And you can also see like these expandable sections, which you can which you can add to the sidebar, or as well also to the main page. And so this one was built around geometry, parameter study around the so-called Windsor body, which is which should be representative of a very basic car body. And so actually, like, what is really at the heart of these dashboards, and this is actually something I really want to emphasize, because this is also showing that, of course, most of the work is done up front. So this kind of dashboard, it does not do any kind of post-processing itself. So it is just displaying the data which has been assembled up front. So it's just for displaying the data and screening through the data. But everything else in terms of integral variables and also contour plots and everything, all of this needs to be created upfront. So yeah, the best way actually to do this is if you have an automated process, and for example here I was running like altogether 64 designs, and then I assembled later on as a database just a table. And here I assembled all of my objective functions, which I wanted to check. So as I said, it's a case representing a basic car body. So of course here we were interested in a drag coefficient and lift coefficient. And as you could see with the parameter space, so I was varying 3 different geometric parameters. So the front length, roof length, and back length. So here is really just the pure data table showing all of the objective function results and the parameters which I varied. On top of this, like under the hood, this data table actually also serves as a data catalog. So later on, we will see that we can also check out contour plots. And these are stored as PNG files. And so in this table, actually in every row, for every design, I also have pointers pointing to the respective files. So giving the path to this picture. And so just to make this clear, so having this table, which serves as a database for showing parameters and results and containing all the metadata and containing file pointers to pictures or other elements, what you want to show, that is the main part of the work, and this is like the base, the heart, what is needed to create such a dashboard on top of it. Okay, so now we have seen like the how the geometries look like, what the data table looks like, and now we can check out some XY plots. So now here, for example, this is just some, it's just basic scatter plots, so it's nothing fancy about this. So now here, for example, we can check out the front length on the x-axis, and on the y-axis we check out the drag coefficient. So now we can see how the drag coefficient behaves depending on the front length. And so just for the second plot, we can do something very similar and can check out for the lift coefficient. And now what I think is now the nice thing is, and what actually shows the interactive capabilities, is that now you can do some filtering. So now you can really shrink the parameter space, and then you can actually see which parameter has which impact. And so just by giving these dots different colors, you can already, just like screen through the data and really find out about the impact of different parameters onto your objective functions. So that's just showing some scatter plots. Then as I mentioned, we also have some 2D plots. So here we can now also just now for this selection, now we can check out the respective geometries. So if we enlarge this again, then also this changes. So here you can see the different designs. And also not just the geometry, but we can also check out the mesh or some contour plots for pressure or whatever we would like. So for velocity. And I think this is just something, being able to perform these filtering functionalities while looking at the contour plots. I feel that this is really something which is super nice. Being able to screen through results and perform some live filtering of the data, and then really check out the impact of these parameters. Okay, then another thing, what is actually most known in the machine learning community for showing the impact of hyperparameters for building machine learning models. It's this kind of parallel axis plots. Which is also like super nice because here then you can make selections of different areas. You can screen these selections, and by that, for example, find out, okay, do I have any similarities between the designs which all have a low drag coefficient? Do I see any kind of patterns when it comes to my parameters? That's also super nice. And yeah, another thing what is also really nice, and there we are now yeah, getting a bit deeper into the data science, and not just only displaying stuff, but also calculating, but what is actually more like a byproduct usually. So is really to calculate the feature importance. So to find out, okay, which of my parameters has the biggest impact onto my objective functions. So here now I can check out which of my geometrical parameters has the biggest impact on the drag coefficient, or I can also check out which of my geometrical parameters has the biggest impact onto the lift coefficient. And then what is also included right now here, but that's to be honest not super nice in this version. So I will update it at some point because this has been done with Plotly, but now a way better library to have interactive three-dimensional plots is available with using PyVista. So yeah, so actually this is my recommendation here for you if you also want to include 3D plots which are really responsive and nice to handle interactively, then use PyVista. Okay, so that was the one example. And then I just want to show another example which I built for an automotive CFD prediction workshop where a lot of software vendors, but also car OEMs participate to show their abilities to run CFD for a specified benchmark case. So, for example, for the case 2, it is always the drive air geometry, and the mesh is provided by this workshop committee. And so everyone who participates just takes this mesh and the geometry and runs CFD. Also, all boundary conditions and everything is fixed, and so everyone is supposed to run the same simulation. So the goal of the workshop is really to find out the differences in the setup of the different simulation runs. So find out impacts of different softwares, different turbulence models, and all of this stuff. And so all of the participants then submit their results and submit their data to the committee. And beforehand, then the committee members did cross-plotting and the evaluation of all of these results manually. So having large Excel tables and then creating plots from these. And now we have switched to also to this kind of interactive dashboard. And so here we can see that we had over 90 participants this time. And now here we can see the drag coefficient Also, the nice thing about this workshop, but that's just on a side notice, is that here, for example, we do have experimental values to compare to, so we can really see which simulations perform well. And so then here, for example, the filtering is then used to, for example, filter for different turbulence models. So now here we can see, okay, for LES, it has been 4 simulations or 4 participants who performed LES simulations, or we can also check for DES, then we can see it's a bit more. And yeah, so this kind of filtering here. And another thing actually here is also what's quite nice is to have some drag and lift development plots. And now here in these line plots, we are also really able to see the differences between different participants, and yeah, can also zoom in and really see which participant submitted which results. So having said this, so that was like really just on the motivational part. So what you can actually do, build with it. So these 2 examples which I showed, they are also hosted in the cloud. I will also share later on how the architecture for something like this looks like. So these are not hosted on the Streamlit cloud itself, but then they run in containers. I run them on AWS because they are a bit more resource intensive, also with the data. Yeah. So with this, I think we can check out the coding, how to get started with something like this. Let me get a new window. So what's another thing, what is actually also really nice about Streamlit is that you can code and see what is happening while you are doing this. So that is really nice. So let me check. Oops. Why? Don't know why I cannot open this right now. Just give me a minute. I'm sorry, something is somehow broken here. I cannot create a Python file right now, but then we will just check out one which is already there. So then it's not, yeah, we can still do some live coding. That's fine. Yeah, because so what I wanted to say is that you can see that you can actually see the impact of your coding while you go. And so in order to do that, so now I do have already this simple file here. So then to run this, we just have to navigate to this folder. So that's now. So we just have to call Streamlit and run dashboard. And now we can see this example dashboard live here. And I will just put this a bit to the side. So it's not the nicest way now on this small table, but I think you will still get the idea. So for example, so just for writing something, it is really just like, so I have imported Streamlit as a ST. So for writing a title or for writing any kind of text, it's just as simple as this. And so now here now in this file I'm sharing here, I already have created a function which is also making use of some caching capabilities. But this is already something you don't even need this. So if you really get started from scratch, then you just need to import Streamlit. And then you can just type streamlit.write and then you can already go. So, and just to show you how easy it is to see the changes actually is so okay. Then if I save the file, then I can see already on the left-hand side, okay, the information that the source file changed. And then if I click on always rerun, then the dashboard is automatically updated. And now you can see here already what I added here. So one way of structuring the layout, what I want to share with you is actually the paradigm of columns. So you can make columns, and also a way of showing content or hiding content is by checkboxes. So if I check my checkbox, then all the other content which comes afterwards is actually shown. And if the checkbox is unchecked, then it's hidden. So we can check it out here. So here, if I say show columns, then I can see that I have created 2 columns. And in the first column, it's just mentioning hello. And in the other column, it's just a nice cat image shown. And then if I uncheck the box again, then it's hidden again. Then another point or yeah, another element to design your layout of your page is are these so-called expanders. So here I can just create this expander and then also write something into this. And that's also quite nice in this box. And I can just select if I want to disable or enable this. Then we also have a sidebar here. So that's also something nice. You have seen this before in the two example pages, and that's actually also super easy. So I just create this sidebar by calling Streamlit sidebar. And then what is in the sidebar also inside is a so-called select box. So here I can give a title to the select box and provide then the values from which one can select. So here for the select color, then I can select these different colors in this sidebar. Another thing, what I personally think is also super nice is that a lot of data structures are supported by Streamlit natively. So one of them are data frames. So when I also just make Streamlit write the same as I did here for just some normal text, if I perform the same command on a data frame, then the data frame is actually displayed in this nice manner already without putting any more effort into this. Yeah, so then the next thing, what we have also seen in the previous ones, what I found is it's also like really nice in combination with some filtering functionalities are the scatter plots. So here I have just one scatter plot here. So here, for example, I also just have the possible selections pre-populated with the column names of my data frame. So just with these two lines, I can already create these select boxes. And here, as we have seen before, then I can select my different parameters and objective functions. And then here actually for the trace itself. So here I make then I use the selected color. So when I change this, then we can see how the color of the scatters is changing accordingly. And yeah, so that was it actually for this simple example. So when it gets when it later on actually gets a bit more complicated and you want to share more data, then what I, for example, then also did for these cases is that you can store all the data which you want to share. If you store the data as well in the cloud, and your pointers to the data files are just a URL link, then it's also really easy to share this. And this is actually something what I did for this app, and so I haven't fully pushed it yet, but it will be available in my GitHub account as repository. So then you will also be able to download the source code for this overall dashboard, and the links which will be used for displaying the pictures will work out of the box, because I have stored them in a public accessible bucket. Okay, so having said this, what else did I want to show? Yeah, the deployment of these apps in the cloud actually. So let me get back here. So as you can see, this was this was now the app which we developed locally. So it's running on localhost. But now, so as soon as you have shared your or stored your dashboard, your Streamlit project, so to say, and you made it available in a public GitHub repository, then you can create also an account on share.streamlit.io for free. And then there you can also host your apps. So this is what I've done here. And now we should be able to see the exact same exact same page, and this one now is running in the Streamlit cloud, based on the repository stored in GitHub. Yeah, okay. So let me come back here. Yeah, so I think just like the last thing, what I wanted to share is just when it comes to a bit more data intensive applications. So yeah, and because the Streamlit cloud is limited in terms of resources. So if you need more resources, then you might also go to another cloud provider. So then I found it quite easy to have everything in a Docker container. And then you can have a cloud-based container registry. And from this registry, you can then have a service which just runs and then also points to a specific URL. Yeah, and with this, I am actually already finished. I think I got now a bit faster because of my Visual Studio Code. It was not working as I wanted it to work for now. But I hope you still got the idea of the interactive development and that you are able to see the impact of your coding right away. And yeah, as I said, so the one dashboard which is also hosted on the cloud, and also the dashboard for this example, what we looked here. So these are will be available on as GitHub public repositories. So yeah, please feel free to ask any kind of questions, or also later on when you have some trouble with yeah, with the code actually provided in the repositories, just yeah, don't hesitate to contact me and let me know.
Amazing, Astrid, thank you so much. One question though, maybe you mentioned this during the talk. What data types are allowed to actually work with? Is it like OpenFOAM specific? Is it?
Right. Yeah. So yeah, it is actually so for this case, what I'm showing here, where we are really also looking at these two-dimensional plots. So this is completely solver agnostic, because it is all based on the previously post-processed data. So, I mean, here I'm really just displaying PNG plots. And then I think the only limitation, so to say, or it will bring a bit of effort with it, is actually for three-dimensional data, because as well for to make it use with Plotly or to make it use also with PyVista, you have to kind of convert your solver data to the respective data structure of PyVista or Plotly. But yeah, that's like the only maybe a bit more coding intense part.
Got it. Okay. Maybe a funny question. When you run that service on AWS, how much does it actually cost you per month or maybe per week? Do you have like an estimate?
Yeah, so it does depend. So for example, this one actually it's pretty cheap, but this one this is really data intense, and here I use for my AWS, I use AWS Fargate for hosting the service, and I think I use 4 vCPUs alongside with 4 gigabit of memory. And this one does cost me per month, I think, like $150.
Oh, okay.
Yeah,
It's
but
quite a
it
lot
is.
actually.
Yeah, but it is actually also a bit oversized. So yeah, I was actually also monitoring the usage. So then of course you can monitor how much of the CPU and memory is used, and I was always way below 50%. But I wanted to keep it that high. Just I don't know. I cannot even tell you because it's also with auto scaling, so it should scale automatically even when a lot of users are actually looking at it for the same time.
Okay, interesting. Cool. Any questions from the audience? Otherwise, you were quite quick, but that's no problem.
Yeah, as I said,
I mean,
that was a bit different as expected.
as always, we had that so often during the cohort, so no worries. People would be able to actually fork your repo, right, and just work on
Yes.
it themselves. Yeah.
Yes.
I assume they would host it locally then with a local host and can play around with it. And then if they would want to host it on AWS, I think it's rather straightforward, quote unquote, right?
Yeah, because like then yeah, especially as so it's the easiest way to do this is really to store all your data in the cloud and just work with URLs as file pointers, because then you don't have to change anything. So for the first version which I had, I was not doing this, so I was putting the data as well into the Docker container, and then like the absolute path to the data changes whether you run it locally or in the Docker container. So then then I just had to differentiate between these two cases. But yes, since I switched to the URL links, then it's really easy. And then it's also just the file what you need to have in your repository. So just the Python file containing the code for the dashboard itself, but you don't need to have the data in your repository, what is also, I mean, the way it should be done, and it's way cleaner and more lightweight anyway.
Got it. Cool. All right. Any questions, guys? Otherwise, we'll give Astrid back some time, some precious time. Maybe any questions? I mean, in any other case, they can just contact you via LinkedIn, I guess, or via email. Pretty straightforward.
Yeah, of course. Yeah, or yeah, I mean also via GitHub. Yeah, I'm happy to share this and happy to answer questions if they arise.
Nice. Right. If there are no more questions, Astrid, thank you so much. Really appreciate it. The recording will be available probably on the weekend, guys. So thanks again, Astrid, and hopefully see you in the last week, which is next week.
Yes.
Last time.
Looking forward to it. Okay.
Take care. Bye-bye.
Thanks for having me. Bye.
Sure. Bye.